Hello, I welcome you all to your own channel. In this video, we will solve one numerical problem which is based on the stability of a four-wheel, or you can say the gyroscopic couple. So we have one problem on the screen. A rear engine automobile is traveling along a track of 100-meter mean radius. Each of the four-wheel road wheel has a moment of inertia is 2.5 kilogram meter square and an effective diameter of 0.6 meter. The rotating part of the engine have a moment of inertia is 1.2 kilogram meter square. The engine axis is parallel to the rear axle and the crankshaft rotates in the same sense as that the road wheels. The ratio of engine speed to back axle speed is 3:1. The automobile has a mass of 1600 kg and has its center of gravity 0.5 meter above the road level. The width of the track of the vehicle is 1.5 meter. Determine the limiting speed of the vehicle around the curve for all wheels to maintain the contact with the road surface. Assume that the road surface is not cambered, right? So you have one automobile is given whose mean radius is given, right? The speed you have to find, limiting speed you have to find so that it cannot be skid right now. So basically what you will do, first of all, the condition we should satisfy that for limiting speed of a vehicle, right? Before that, we will find out the reaction due to the gyroscopic couple and due to the overturning couple. So first we'll write down the given data. That here will go. You can write the question and then write down the given data. So our solution is a rear engine automobile is traveling along a curved path, that is radius is given r is equal to 100 meter. And each of four road wheel has a moment of inertia is this one, that is each of four road wheel, that is mass moment of inertia of a wheel is given, which is IW is equal to 2.5 kilogram meter square, and the diameter of the wheel is given, DW is equal to 0.6 meter, means RW radius of the wheel is 0.3 meter, and the moment of inertia of the engine is given 1.2 kilogram meter square. Okay, and the gear ratio is given, that G is equal to, you know, the angular velocities of engine by angular velocities of wheel, right, is equal to 3:1, means 3 is given. And the mass of the vehicle M is given, which is 1600 kilogram. Okay, and the height of center of gravity, that is H, is given to you, which is 0.5 meter, right, and the width track, that is X, is given 1.5 meter. So based on that, you have to find out the, first you need to find out the gyroscopic couple due to the wheel and engine. Before that, we will find out the road reaction, right? So here we can say the road reaction over each wheel is what, W/4, you know. So first of all, we will find out the road reaction, road reaction over each wheel, So what is the road reaction over each wheel? That is nothing but the W/4, means mass into gravity by 4. That mass is 1600 and the gravity will take 9.81 by 4. So the road reaction on each wheel is nothing but 3924 Newton, right? Then we will find out the gyroscopic couple. So we can imagine, let the limiting speed of the vehicle is V meter per second. Let the limiting speed of vehicle is equal to V meter per second, right? That velocity we have considered. Then angular velocities of wheel. So omega W, we can say angular velocity of wheel, right? That is omega W is equal to V by RW, means radius, velocity by radius. So velocity is velocity only and radius is 0.3. So you have a 3.33 V meter per second. That V is the velocity, right? Then you have to find out the angular velocities of precision. Angular velocity of precision. So angular velocities of precision is what? That is omega P is equal to V by R, right? So V is V only, R is 100 meter is given, which is 0.01 V, right? This is also in meter per second. Now we have to find out the gyroscopic couple due to the four wheel, right? So you can say gyroscopic couple due to four wheel, right? So gyroscopic couple is what? CW is equal to 4IW omega W into omega P. Gyroscopic couple is I omega P, you know, right? So omega W is for the wheel, IW is for moment of inertia of wheel, and omega P is the angular velocity of precision. So you have all the values is there. 4, IW is given 2.5, omega W just now we have calculated, which is 3.33 V. So 3.33 V, and omega P is 0.01 V, right? So on calculation, this value will be 0.33 V square, right? Gyroscopic couple we got. The unit will be Newton meter. Okay. So gyroscopic couple due to wheel we got. Now we find out the gyroscopic couple due to the engine, right? So wait. So now you have a gyroscopic couple, right, due to engine, due to rotating part, you can say, or due to engine, right? So this is what you have, a CE is equal to IE omega E into omega P. So moment of inertia of a engine is given, which is 1.2. Omega E is the, you have a gear ratio is given, so omega E is nothing but a 3 into 3.33 V, right? And omega P is what, 0.01 V here. So you can say gyroscopic couple due to engine is what? Gyroscopic couple due to engine is 0.12 V square Newton meter, right? See that gear ratio is given 3. So gear ratio is omega E by omega W, right? So omega E is equal to what? 3 times of omega W. This is omega W value we have taken. So gyroscopic couple due to engine we got. Now we need to find out the total gyroscopic couple. Okay. So we will see the net gyroscopic couple or total gyroscopic couple, you can write. That is total gyroscopic couple, right? Total gyroscopic couple. So C is equal to CW. Actually it is plus minus, but means wheel and engine are rotating in the same sense. It is given in the question. So we have a CW plus CE. So gyroscopic couple due to wheel we got, which is 0.33 V square, and gyroscopic couple due to engine we got 0.12 V square, right? So it is 0.45 V square, that net gyroscopic couple we got. A total gyroscopic couple due to wheel and engine we got, this which is 0.45 V square Newton meter, right? Now what we need to do, that because of this gyroscopic couple, the reaction will act, road reaction will act, which the vertical reaction will act. That vertical reaction will be upward on outer wheel and the inner on downward on the inner wheel, right? So and that magnitude of that road reaction we will denote by P by 2, right? So you can say here the vertical reaction due to this gyroscopic couple is, you can let vertical reaction, Rxn is the vertical reaction due to the gyroscopic couple, is P by 2 on outer and inner wheel, right? So we have a P by 2 value, you know, that is C by 2x. Okay, this discussion we already done right now, so you can check in the previous videos. So P by 2 is equal to C by 2x. C is 0.45 V square by 2. Width is given 1.5. So here you have a, that is P by 2 is equal to 0.15 V square. So the road reaction due to outer wheel we got, due to the gyroscopic couple we got. Now the vehicle is taking turn, so centrifugal force will act. So first of all we will find out the centrifugal force, right? So centrifugal force, right? So centrifugal force is what? Fc is equal to mv square by r, right? By r. So mass of the vehicle is 1600, v we have to consider, and r is 100. So centrifugal force you got, that is Fc is equal to 16 V square Newton, right? Centrifugal force you got. Due to this centrifugal force, the overturning couple will act, which we call it as a C naught, right? So now you need to find out the overturning couple, right? So overturning couple is what? That C naught is equal to Fc into height of the center of gravity from the road surface. So this is 16 V square, and height of the center of gravity is what? Which is 0.5, right? So it will be 8 V square Newton meter. This is overturning couple we got. Due to this overturning couple, the reaction will act on the vehicle, right? That is Q by 2 we can say, right? So again, so here you can say just wait. So now we can say that due to overturning couple, the vertical reaction will produce, right? That is, which is we are denoting by Q by 2, right? So this Q by 2 on upward on outer wheel and downward on the inner wheel. So this Q by 2 magnitude is what? That Q by 2 is equal to C naught by 2x, right? So C naught we already got, that is 8, right? So here you have a 8 VA square by 2 into 1.5. So Q by 2 you got, which is 2.67 VA square, right? So we got the road reaction, right, over each wheel due to the weight of the vehicle, vertical reaction due to the gyroscopic couple, as well as the vertical reaction due to the overturning couple. So total reaction on outer and inner wheel we will see. So here you can say the total reaction on outer wheel, right, is equal to what? W by 4, and the vertical reaction due to gyroscopic couple is P by 2, which is upward on outer wheel, and vertical reaction due to the overturning couple, which is Q by 2, is upward, W by Q by 2. And again, so you have to put the magnitude. Again, total reaction on inner wheel, right, on inner wheel. So that is what? That is W by 4, vertically upward on the outer and inner, and downward on the outer wheel, inner wheel, that is minus P by 2, and this is due to overturning couple, the vertical reaction is also downward on inner wheel, so it is minus Q by 2. So this vertical reaction, total reaction on outer and inner wheel we got. Now the question is that you have to find out the limiting speed of the vehicle around the curve for all four wheels to maintain the contact. As you know, when the vehicle is taking a turn, the outer wheel is in contact with the road surface, right? And the road surface means that W by 4, P by 2 and Q by 2 is vertically upward. So when we have to maintain the contact with the inner wheel, right, the road surface to the road surface, the reaction on our inner wheel should also be vertically upward, and it will be possible only when this condition will be satisfied, right? So you have to maintain, you have to write, right, to maintain the contact with the road surface, to maintain the contact with the road surface, right? What is the limiting condition? The limiting condition is nothing but that P by 2 plus Q by 2 should be less than equal to W by 4. Why this condition? Why? Because in outer wheel all the reaction are upward, but in our inner wheel that reaction due to gyroscopic couple and overturning couple is downward. Okay, so to maintain the contact, that vertical reaction due to the gyroscopic couple and vertical reaction due to the overturning couple should be upward, and it will be possible only when these two reaction, their summation should less than equal to W by 4. So here you will go, P by 2 you already calculated, which is 0.15, right, 0.15 VA square, and Q by 2 you got 8 VA square, right, is equal to, I am taking W by 4 less than equal to W by 4 means is equal to, right. So this is 3924. So when you simplify this, you will get the answer that V is equal to, so simply you can add this and square root, right. So your velocity will be, which is 37.3 meter per second, right. So this is your answer. So this is the limiting speed. At this speed, the contact road surface will be, means the wheel will be in contact with the road surface. Thank you.